Hi students, our study today is about random variable. This is the last part of probability. A random variable is a variable that takes on different values as a result of the outcomes of a random experiment. In other words, a random variable is a function from a sample space into set of real numbers. So this is the most important set of real numbers. Let us take an example. Suppose, for example, you have a coin and you want to flip a coin 3 times. You're going to get tail, 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 or tail and 2 head, or head, tail, head, or tail, head, head, or 2 tail and the head. It can be this way. So we have 8 outcomes, or head, tail, tail, or 3 head. Okay, so now this is a sample space where you have letters. A random variable, it will translate all of these letters of the outcomes into set of real number. I'm going to say, for example, as an example, let x be denote the number of heads. So it's number of heads, number of heads. So what will be this random variable? It will be x will be, it can be a number of heads. Either you have 3 heads, or first of all, let us start by 0 head in all are tail, or you may have 1 head like these. Here you have 1 head and 2 tail, or you may have 2 head, or you may have 3 head. So here what happened? We had a sample space, as you can see, and we translate it into set of real number such that p of 0 plus p of 1 plus p of 2 plus p of 3 is 100% is 1. So it makes everything. So for example, if I say I want p of 0, p of 0 yani no head, all are tail. So it's because independent, so half times half times half, it's 1 over 8. So p of 0 is 1 over 8. P of 1, it means I have only 1 head and 2 tails. 1 head and 2 tails like this, so it's half times half times half, half 1 over 8. How many times? It's 3 over 8. So P of 1 is 3 over 8. Similarly, P of 2, I want 2 head and 1 tail. So also I have a 3. Each one is half times half times half, so it's also 3 over 8. And the last one, P of 3, so I have 3 head, so this is P of 3, so it's 1 over 2 times 1 over 2 times 1. So if you make the sum of all of these, 1 plus 3 4 plus 3 7 plus 1 8, 8 over 8 is 1. So it's a random variable. We solved many problems of random values, but we didn't say it's a random variable. So it's a set, it transform a sample space into set of real number. For example, another example of random variable. So suppose you want to flip, for example, you're going to pick marble. Suppose you have an urn, you have 3 white. Let me give another example, and 4 black. So let x be the random variable, for example. X is a random variable. So the number of pick till we get the first black. So one can say I can draw the black in the first draw. Another one can say I can draw white then black. Here I have 3 white. Or I can draw 2 white and 1 black. Or 3 white and then 1 black. So these are all possible outcomes. So as I said, the number of draw until I get a black. You can, it depends on the problem. So they will give you what is the random variable. So here the first random variable is 1 draw. I may get white and the black, so it's 2 draw, or I may get 2 white and 1 black, 3 draw, or 3 white and 1 black, 4 draw. So here P of 1 plus P of 2 plus P of 3 plus P of 4 is 100%, which is 1. What is P of 1? P of 1, here its order is important. So I'm going to get the first black in the first draw. So I have arrangement 1 out of 4 over 1 out of 7. So I have 4 over 7. P of 1 over 7. P of 2. So I will get first a white first. So 1 out of 3 arrangement. You do the calculation. Then 1 black, 1 out of 4 over 2 out of arrangement 2 out of 7. And if I want to find P of 3, so arrangement, I want arrangement 2 white, 2 out of 3 order important, then this is 3, then 1 black, 1 out of 4 over, I have a 3 arrangement out of, I have how many marble? 7. P of this one, I want the 3 white, arrangement 3 out of 3, 1 black, 1 out of 4 over, I have 4 out of 7. So the sum of all of this is 1. So what is a random variable? A random variable is a set, it's a sample space or called range space, sample space of range space, where the elements of these are all real numbers, such that P of EI, suppose each one is E, P of E1 plus P of E2 plus P of E3 plus up till P of En all are equal to 1. So this is called a sample space, and we denote the universe here by omega x. Okay, universe before, when it was ordinary one, it was omega. Now because it's to denote it's a random variable, we denote it by x. So this is x1 up till xn, and such that the sum is always equal to 1. Okay, so it is set of ordered pairs xi p of xi. Um, so as we said, as we did in the example, what's p of xi? Number of points of S whose image is in xi over number of points in si's, as we did this one here. So you solve an ordinary problem, of probability to solve the probability for each one. So we don't have anything new. Now, when you have xi and p of xi, for example, when we solve these, we have 1 over 7, whatever, we can graph them in tables. Okay, first of all, we can arrange it in that table, in a table. In this example here, the example here in number 1 was the sum of values obtained as a result of tossing a pair of fair dice. Okay, it's the sum when you're going to toss a pair of paired dice. Okay, so when you want to toss a die, two dice, for example, what are possibilities? You have 1 1, you have 1 2, you have 1 3, etc. up till 1 6, and you have, these are ordered pairs, 2 1 up till 2 6 till 6 1 up till 6 6. So what are here? They said in number 1 the sum of values obtained as a result of tossing a pair, the sum of values. So we want to make the sum of the values. So to get 2, I have only one choice, which is 1 1 out of 36 possibility. To get a 3, either you have 2 1 or 1 2. So how many choices? I have 2 out of 36, which is 1 over 18. To get a number 4, either you have 1 3 or 3 1, for instance, or 2 2. So how many choices? I have 3 out of 36. To get a 5, you have either 1 4, 4 1, you may get 2 3, 3 2. Other possibility for 5, I don't have. 4 over 36, 1 over 9. To get a 6, you may have 1 with 5, 5 with 1, 2 with 4, 4 with 2, and 3 with 3. So how many choices I have? I have 5 of 36. uh, Till getting the number of 12, you have 6 and 6, 1 over 36. So what did we do? We had a sample space, the outcomes that you all know. These are the outcomes. Okay, it's ordered pairs of number. We translated into random variable where x is the sum of these numbers. So if you do p of x2 plus p of x3 plus p of x4 up till p of x12, and you make the sum of all of these, you're going to get 100%, which is 1. So here you can graph it in bar diagram. Sorry, you can graph it in bar diagram like this one. Akid, when you want to graph in bar diagram, the maximum you can reach is 1, because probability of 1 is 100%. Impossible to have a probability exceeding 1. So for example, here P of 2 was 1 over 36, P of 3, 1 over 18, etc. up till P of 12. Or you can do it in histogram, this form. I want P of 2, you put 2 and the 3. P of 2, you take the middle B of before and middle after, and you join it as it is here. Okay, now what is expected value of a random variable? The expected value, it means the average that we may expect to get. So it's summation of xi p of xi. So the expected value, it's the summation, because the average, we know that the average before it was summation of xi, of all xi over n. Okay, so here if you want to find the average, 1 over xi and I, if you want, over n. Now an I over n is the probability that we have found now. For example, when you want to toss a die, for example, 1 to get a sum of 3, 1 2 or 2 1. So how many possibility you have? We have out of 36. How many 1? We have 2 out of 36. So this x and I and over n is nothing else than p of xi. P of getting what? 2. So if you want to find the average, you must multiply it by xi, which is 2. So this is summation of xi p of xi, which is called the expected value. What do we expect to get? Okay, it's called it's the same as average. By definition, expected values is summation xi p of xi. Okay, if you want to do the expected value of the problem we did before, so what do we do? It will be 2 times 1 over 36 plus 3 times 1 over 18 plus 4 times 1 over 12 up till 12 times 1 over 36. It means if I want to do this experiment many times, hundreds times, whatever, what do I expect to get? I expect to get, for example, a number which is 7. So I hope that you got the random variable. It's very simple. Now we're going to go and do some problems of random variables. Two fair dice are rolled. Let S be the random value that associates to every roll of the two dice the product of the appearing number. So because I want the product, so if you have 1 with 1, you have product is 1. If you have 1 with 2 or 2 with 1, for example, you have 2. If you have 1 with 3, 3 with 1, you're going to get number 3. If you have 4, 2 with 2, 1 with 4, or 4 with 1, you have number 4, etc. So here they said let S be the random variable that associates to every roll of the two dice the product. So here I want to roll the two dice. This is called sample space up till the number 6, which is 36. 6 and 6. So this is the sample space. I want to translate it, as they said, into product. So these are the numbers that you may get. So here to get a number 1, so how many choices you have? I have only 1 out of 36, so 1 over 36. To get a number 2, it's either 2 1 or 1 2, sorry, or 1 2. So how many choices I have? 2 out of 36. So get a number 3, it's 1 3 or 3 1. 2 over 36. To get a number 4, for example, I have 2 2, 1 4 4 1, 3 out of 36. To get a 5, you have 1 5 5 1 only. So 2 out of 36. To get the number 6, you have 6 1, 1 6, 2 3, and the 3 2. So how many choices you have? 4 over 36. To get 8, you have 8 1 4 4 1 2 2 4 4 2 9. You have to get 9. Yes, we have 3 and the 3, so one choice. 10, you have 5 2 and 2 5. 12, you have 2 6 6 2. Okay, 4 3 3 4, etc., etc. So if you make the sum of all of these, you're going to get what? 1. And if you want to find the expected value, what do you expect? You do 1 times 1 over 36 plus 2 times xi, it's summation xi p of xi. What do we expect if you want to play this game to get the most often, the average? It means what do we expect to get? So we expect to get, if you do 1 times 1 over 36 plus 2 times 2 over 36 plus 3 times 2 over 36 up till 36 times 1 over 36, I expect to get 12.25. So concerning the variance and standard deviation, it's cancelled, so we don't have it. Now another example, a nerve contains 5 balls. We have 2 white, okay, 2 white and the 3 black. We have 2 white and 3 black. Till now it's not a random variable. So now the question, balls are drawn one after the other till the urn is emptied. Let X, we're going to draw all the 5 balls one after the other. Let X designate the rank of the white ball when it appears for the first time. You're not going to give me one example and this is the only example. You're going to put all possibilities of position of the white. One can tell me the white can come first. Another one can tell me we get B, then white. Another one can tell me B, white. One can tell me B, white. Do you have other choices of position of white? Certainly no. Either it's in the first position, or second position, or third position, or fourth position. So what are the possibilities of the random variable, which is the set of real numbers? It's 1, 2, 3, or 4. So the first question, determine the law of x in the probability of x. So P of 1, it means getting a white. So since I have 2 white, 3 black, arrangement order important. So it's 1 out of 1 over 1 out of 5. So 2 over 5. To get P of 2 to be the white to be the second position, I need to get a black first. So 1 out of 3 arrangement, then 1 white, 1 out of 2 over 2 out of 5. To get it here, I need to get 2 black. So 2 black, I mean here 2 out of 3 and 1 out of 2 white over the 3 out of 5 arrangement. And to get the 4, I need to have a 3 black, 3 out of 3 and 1 white after 1 out of 2 times 4 out of 5, so we have 1 out of 10. And the expectation, we don't have the values as we said, so we expected value, it will be summation xi p of xi, so it will be 1 times 2 over 5 plus 2 times 3 over 10 plus 3 times 1 over 5 plus 4 times 1 over 10. And we expect, if we want to play this game, to get 1 point, to get the white after 1.6 draw. Number 3, an urn contains 4 balls carrying the number 1, 2, 3, 4, out of which 2 are randomly drawn without replacement. I want to draw two balls from this draw. Let A be the number on the first drawn ball and B the number on the second. Let X be the smallest among these two numbers and let Y be the biggest between the two numbers. Determine the law of probability of X and Y. I want to draw balls. Either you're going to draw. What are all possibility? Either you draw B1 without replacement, then B2, or you draw B1 and B3, or B1 B4, or you draw B2, you put the sample space B1 or B2. I cannot have B2, 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 B3, or B2, B4, or I draw B3, B1, B3, B2, B3, B4, or I draw B4, B1, B4, B2, and the last one, B4. So how many choices I have? I have 12 choices. A is the smallest. A the smallest between 1 and 2, so 1, and the smallest between 3 and 4 is a 3. So you may have 1, 2, and 3. And if you want the greatest, so between 1 and 2, so here is 2, here is 2, 3, 3, 4, 4, 3, here 4, 3, 4, 3, 4. So you have 2, 3, 4. So what's P of 1? P of 1, how many times you may get minimum 1? So this is for x, 1. Here you pick 1, 1, 2, 3. Here what? 4. So I have 4. Do we have more than getting here 1, 2, 3. Here I have 1, 4, 5. Here I have 1, 6 over 12. B of 2 minimum, I want the minimum. So B2, B3 it's minimum. B2, B4, here B2, B4, B2, B3. So how many choices I have? I have 4. And to get number 3, the rest, B3, B4, B4, B3. So 2 out of 12. For maximum, the same thing. For example, to get 2, you pick B1, B2, B2, B1, till now we have 2. I don't have then this maximum. To get number 3, you may have B1, B3, maximum, B2, B3. You may have here B3, B2, and B3, B3, B2, and B3, B1. So 1, 2, 3, 4. To get a 4, so you have choices. Let us see on. I don't have 4 here. This is 1. Maximum is 4. 1. Here another 1, 2. Here 3. Here 4. Okay. Here 5 before B1. And here 6. So 6 out of 12. So if you make the sum here, it's 1. If you make the sum here, it's 1. They want the expected value. So it's summation xip of xi. So 1 times 6 over 12 plus 2, whatever, it's 5 over 3. And if you do the other one, it's 10 over 3. You realize that this one is double than the first one. We don't have the variance as we said. Another problem, 7 horses successively enter a racetrack where 3 are white and 4 are black. We have 3 white and 4 black. Now, what is the question? The question is determine probability for the first 2 horses to appear to be white. So order importance. So A 2 out of that the مش the first. I thought the first 2. The first horse to appear is white. So 1 out of 3 over 1 out of 7. So 3 over 7. Let X be the random variable present the rank at which the first black horse appeared. The first black horse appeared. Let X be the random variable presenting the rank at which the first black horse. So you're going to tell me I may get the black horse from the first time. One tell me I can get white then black. One can tell me I get white. I want to put all possibilities, then black and white, 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 black. So because I have 3 white, so either 1 or 2 or 3 or 4. So P of 1, so to get 1 black, so 1 out of 4 over 1 out of 7. To get here from the second one, so arrangement, the first one must be here is white. I have 3 white, so 1 out of 3 and 1 here, 1 black, 1 out of 4 over 2 out of 7. Here you have white, then white, than black. The first two are white, so arrangement 2 out of 3, 1 out of 4, and for this one you do this one. So if you make the sum here 100%, it is 1. Remains two problems to talk about. Given two urns A and B such that the urn A we have 5 white and 4 red and 1 green. Urn B you have 5 red, 7 green balls. A student draw at random one ball from the urn A. We want to draw one ball from the urn A. If the drawn ball, again, we're going to put it here. We are in urn A. If the drawn ball is white, then the student does not get anything. If the drawn ball is green, so suppose it's green, he get 10 points. We solve similar problems. If the drawn ball is red, the student draw randomly one ball from B. If it's red from B here, we're going to put B, he goes to B. If it's red, he get 5 points. If it's green, he again draw without replacing the ball in B, another one from B. If this last ball is red, so if it's green, he draw again another ball from B. If it is red, he get 2 points. If not red, it means green, he got nothing. He will not get anything. Okay, what is the probability of the event the student does not get anything? Not to get anything, so what student does not get anything from the draw from urn A. From urn A, we said if you draw a white, then the student does not get anything. So here we did forget to put 0. So from urn A, yani he's going to draw from urn A white ball. To draw white knowing from urn A. From urn A, I have 5 white. So 1 out of 5 over 1 out of 10 is 5 over 10. So as we said, I want white does not get anything from urn A, so he must draw a white. So white I have 5, 1 out of 5 over 1 out of 10, so 5 over 10. The second one, calculate the probability of F. What's F here? F, the student gets 5 points, so 5 points here. So he must draw first of all, as you can see here, let me put it laser. From urn A red. So red knowing A, then he's going to get a red knowing B. So independent because he's going to draw from each one. So a red from A is 1 out of 4 over 1 out of 10, so 4 over 10. And the red from B, 1 out of 5 over 1 out of 12, so 5 over 12. Then what is the probability of getting M? The student get 10 points. The 10 points here from A. From urn A knowing green knowing from A, so this is what green I have 1, so 1 out of 1 over 1 out of 10, so 1 over 10. Now probability, deduce that this is probability of E. The student gets 2 points. So 2 points, where is the 2 points? The student gets 2 points. There is something 2 points we didn't write. Let me see. If it's red, he get 2 points. So here the mistake. So here you must have, we don't have a 3, it's 2. Okay. So now to get 2 points, he must draw a red from A. Red knowing that from A. Then he want to draw in order green, then red from B. But because he's going to draw it without replacement and order important, so this is arrangement. He's going to draw a green first, so arrangement 1 out of 7, then a red 1 out of 5 over 2 out of 12, so 7 over 66. You realize that these problems we used to do them, but we didn't call them that random variable. Now it's already you know these. Now calculate P of n. The student does not get anything. So not to get anything, either he's going to draw a white from A or red from A, then followed by two green from B. I have the red from A, so I need only to do now to add to it this is P of n does not get anything. I can do it in two ways. Either because I have the 2, I have the 5, I have the 10, I do 1 minus these 3, or I do it all because I know that the sum of P of 0 plus P of 5 plus P of 2, P of 0 plus P of 10 plus P of 5 plus P of 2, and these two 0 together is equal to 1. So I can do 1 minus these, or I can say this is arrangement. First of all, to get a red from A is 1 out of 5 over 1 out of 10, so 5 over 10. Then I will arrangement, I want two green. So here I say, if I want to do it in another way, instead of doing it this way, so as we said, it's 5 over 10 times arrangement 2 green, 2 out of 7 over 2 out of 12. So if you solve it, you're going to get in calculator 69 over 110. Now we're going to transform it into a random variable. Designate by x the random variable that's equal to number of points received by the student. So this student will receive either 0 or 2 or 5 or 10. I have everything. P of 0 already we did it. P of 0 was 69 over 110. P of 2 we did it. It was 7 over 66. P of 5 we did it. It was P of f 1 over 6. P of 10 we did it. It was P of 10 1 over 10, so which is m, and the expected value will be 0 times 69 over 110 plus 2 times 7 over 66 plus 5 times 1 over 6 plus 10 times 1 over 10, so it's $2.045. So if you want to play this game, so you expect to gain 2.045 problems. Now the last problem. So here there are two types A and B of balls placed in a bag. Some of the balls are white, the others are black. If there are, we have 5. I have type A and type, we did here, type A, type B, white and black. Okay, there are, if there are 5 of type A, so type A total is 5, and 4 of type B, 4, out of which 6 are white. I have 6 white, 3 are black. Knowing that there are 3 balls which are white and of type A. White and type A there are 3, so because this is 6, so here is 3. Because here is 4, this is 1. Because here is 3, so here is 2. I have the whole table. Now find the rest. We did it. Okay, now a ball is drawn randomly. What is the probability that is white and of type B? White and of type B, so I have 1 out of 3 choices over 1 out of total 9. Let me see here, where did we do this problem? So let me do it alone. Maybe it's not written. So a ball is drawn randomly. What the probability that it's white or and of type B? So I want it white and type B. So as we said, white and type B, I have 1 out of 3 over 1 out of 9. So it's 3 over 9. I want it white. So white, how many I have? 6. So P of white, so 1 out of 6 over 1 out of 9, so 6 over 9. White or type B? White, this is white, or type B. So how many one I have? 3 plus 3, 6, 7, plus 4, 11, so it's 11. I have 11 choices. So here I have 6 plus 3, 9. So sorry, this is the total. So I want it white and or type B. So I have 3 plus 3, 6 plus 1, 7. Without, this is the total. So I have 7 out of 9. Now, second part of the problem, we draw 4 balls simultaneously. I want to draw 4, we have 9 balls. I want to draw 4. Denote by X the random variable which is the number of the balls that are white and of type B. هلا white and type B I have maximum 3. Either you draw 0. Okay, here how many balls I want to draw? I want to draw 4. From the drawn ball I don't have any one, 0. Or I have one of them. One of the 4 is white and of type B, or 2 or 3 maximum. So this is the random variable. Give the law of probability of X. It's either 0 or 1 or 2 or 3. Draw the curve. I want to find the probability for each one. P of 0. What does it mean, P of 0? I will never draw any one of these. Let me erase here. So this is white and of type B. I don't want any one of these. So I'm left with how many balls? 6. So it will be 0 out of 3. And the 4 that, because I want to draw 4 balls, 4 from the rest in 3, 2, 1 over total 4 out of 9. I want 1. It means 1 out of 3 combination and 3 out of these 6 over total. P of 2. So I have 2 out of 3 and 2 out of 6. I want P of 3, 3 out of 3 and 1 out of 6. If you make the sum, it will be 1. And if you want to find the expected value, you do 0 times 5 over 42 plus 2 times 5 over 14 plus 1 times 10 over 21 plus 3 times 1 over 21. You're going to get 4 over 3. Okay, I hope that you understood the random variable. I'm going to send you within these 2 days. I want you first to watch this video, and on Friday I will send you, or Saturday I will send you another one, and I'm going to see you on your Monday assessment. It's going to be probability, and at the last part will be random variable.